الثانوية العامة قسم العلمي رياضيات لغات. أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج داينامكس. النهاردة إن شاء الله هنستعرض مع بعض موضوع من أهم موضوعات منهجنا وهو موضوع impulse. Dear students of grade 3 secondary, welcome to our method program. Today we have dynamics. Our lesson today is impulse. What is the impulse? If force F of a constant magnitude acts on a body during a time interval t, then the impulse of this force, it's denoted by the symbol I, capital letter, is known as the product of force vector by the time of its action. Then vector I equals vector F times t. According to such a definition, it's clear that the impulse I is a vector quantity in the same direction as the force vector F. Then the magnitude of the impulse I equals magnitude of F times time. Now, what is the unit of measurement of the magnitude of the impulse? We know that the impulse I equals F multiply T. Then, unit of measuring of I equals Newton times second. Newton is the unit of the force and second is the unit of the time. When we use the force in dyne, then I equals dyne second. And if the force in kilogram weight and the time in second, then I equals kilogram weight times second. And we know that the impulse I equals the change in momentum. Then gram weight times second equals gram centimeter per second, or kilogram weight times second equals kilogram times meter per second. Then let us start with the first example. A force of magnitude 25 kilogram weight acts on an object for a time interval of magnitude 1/10 of second. Find the force impulse on the body in Newton second unit. Now, impulse I equals F multiply T. Then I equals the magnitude of the force F equals 25 kilogram weight. Then we multiply 25 times 9.8, then the force F in Newton unit. Multiply the time t equals 1/10 second. Then now I equals 25 times 9.8 times 1/10 equals 24.5. And the force in Newton unit and t in second unit, then the impulse I equals 24.5 Newton second. Another example, the forces F1 vector equals 4I minus 3J plus K. F2 vector equals I plus 2K, and F3 vector equals 4J minus K. These forces act on a body for a time interval of magnitude 5 seconds. The magnitude of the force impulse if the magnitude of the force is measured in Newton unit. Now we have three forces, F1 and F2 and F3. Then F vector equals F1 vector plus F2 vector plus F3 vectors. We use the resultant of the three forces, which equals vector F equals 4 I minus 3j plus k, f1, plus f2, which equals I plus 2k, plus f3, which equals 4j minus k. Then the resultant force equals 4I plus I equals 5I, negative 3j plus 4j equals 1j, and 1k plus 2k minus k equals 2k. Now, vector I equals vector f multiply t. Then I vector equals 5I plus j plus 2k multiply the time 5. Then I equals 25I plus 5j plus 10k. Now we have I as a vector. The magnitude of I equals norm vector I. Norm vector I equals square root of 25 power 2 plus 5 power 2 plus 10 power 2. Then I equals 4 root 30 Newton second, because we use Newton unit for the force F and second for the time. Now, what is the relation between impulse and the momentum? We can write the following relation. The following relation between the magnitude of the impulse vector and the magnitude of the force vector is. We know that I equals Ft. Then I equal integration f dt from t1 to t2. Definite integral the force F with respect to time t from t1 to t2 equals m, the mass of the body, multiply v2 minus v1. v2, m times v2 minus v1 is the change in momentum. Then we can use this relation. I equal the change of momentum equals the area under the curve. Now, another example. The opposite figure represents the force time graph, where the force F equals 1 plus between two bracket t minus 2 all power 2. Find the impulse of the force F within the first 3 seconds. The second required the impulse of the force F in the 5th second, where the magnitude of the force F is in Newton and the time t in second. In the opposite figure, if graph is force time graph between F and t, and the force F equals 1 plus between two bracket t power t minus 2 all power 2, which equals 1 plus t power 2 minus 4t plus 4. Then the force F equals t power 2 minus 4t plus 5. Now, what is the impulse of the force F within the first 3 seconds? I equals integration f dt from t1 to t2. I equals integration. The function f equals t power 2 minus 4t plus 5 with respect to the time t from 0 to 3. The impulse during or within the first 3 seconds, meaning the time beginning from time equal 0 to time equal 3. The definite integral I equal third t power 3 minus 4t power 2 over 2, which equals 2t power 2 plus 5t from 0 to 3. We can substitution and calculate the magnitude of I. I equal third multiply 3 power 3 minus 2 multiply 3 power 2 plus 5 multiply 3 minus between two bracket third times 0 power 3 minus 2 times 0 power 2 plus 5 times 0. Then we can use the calculator. Then I equals 6 Newton in second. Now, what is the impulse of the force F in the fifth second? In the fifth second, from t equal 4 till t equals 5. We know that I equals integration f dt from 0 to t2. But in this case, I equals integration t power 2 minus 4t plus 5 dt from t equals 4 to t equals 5. Because the impulse here in the fifth second only, from t equals 4 till t equals 5. Then the integration of t power 2 is third t power 3, and the integration of negative 4t is equals to negative 4 t power 2 over 2, which equals negative 2 t power 2, plus integration of 5 is 5t from 4 to 5. Then the impulse I equals 1 over 3 multiply 5 power 3 minus 2 times 5 power 2 plus 5 times 5 minus between two bracket third multiply 4 power 3 minus 2 times 4 power 2 plus 5 times 4. We can use the calculator to find the magnitude of the impulse, which equals 22 over 3 Newton seconds. Another example. A body of mass 4 kilogram placed at rest on a smooth horizontal plane and is acted upon by a horizontal force of magnitude 5 Newton for 8 seconds. Find the impulse magnitude on the body and the velocity magnitude of the body after 8 seconds. We know that the impulse I equals Ft. I equals the magnitude of the force equals 5 Newton multiply time equals 8 second. Then the impulse I equals 40 Newton second. And we know that the impulse I equals the change of momentum. Then I equals m multiply between two bracket v minus v node. I equals 40 Newton times second in the left hand side, and the right hand side 40 times v minus 0, because the initial velocity v node equal 0. Then v equals 10 meter per second. Remember that the force here in Newton and the time in second. Then the left hand side Newton times second, and the right hand side m multiply v minus v node, m in kilogram and the velocity v in meter per second. Then the velocity equals 10 meter per second. Another example. A body of mass 3 kilogram moving with velocity vector v equals 5i minus 2j is acted upon a constant force of for a time t, and the force impulse on the body is equal to 6i plus 9j. Find the velocity of the body after the action of the force if the velocity is in meter per second unit and the impulse magnitude is in Newton second unit. Now we have v velocity, v1 equals 5i minus 2j vector, and the impulse I equals 6i plus 9j. And we know that I equals the change of momentum. Then I vector equals m multiply v2 vector minus v1 vector. In the left hand side, vector I, which equals 6i plus 9j, equals, in the right hand side, the mass of the body equals 3 kilogram multiply v2 minus v1. Then divide by 3, the left hand side 2i plus 3j equals the right hand side vector v2 minus 5i plus 2j. Then the vector v2 equals 7i plus j. Now what is the magnitude of the velocity? The magnitude of the velocity v2 equals norm vector v2 equals square root of 7 power 2 plus 1 power 2. Then the magnitude of vector v2 equals root 50 meter per second, and v2 equals 5 root 2 meter per second. Dear students, note that when a body of weight W falls vertically on the ground, then the pressure of the body on the ground equals reaction of the ground on the body. Then the pressure of the body on the ground equals F plus W. F, the force of the action of the body on the ground, and W is the weight of the body, then R equals F plus W. And when a body of weight W is projected vertically upward and collides with the ceiling of a room, then the pressure of the body on the ceiling equals reaction of the ceiling on the body equals F minus W. Then in this case, R equals F minus W, or F equals R plus W. And when a body of weight W is projected horizontally and collides with a vertical wall, then the pressure of the body on the wall equals the reaction of the wall on the body equals F. In this case, F equals R, where F is the magnitude of the impulsive force in each of these above cases. Now, example, a rubber ball of mass quarter kilogram fell down from a height of 10 meters above the ground and rebounded after collides with the ground for a height 2.5 meters. Find the impulse resulted from the collision or impact of the ball with the ground, and identify the reaction of the ground on the ball if the contact time of the ball with the ground equals 1/10 of second. Now we have point of falling and initial velocity v naught and distance 10 meter, and we know that the gravity g equals 9.8 meter per second squared. Now what is the velocity before the impact? The velocity before the impact with the ground directly is v, and v squared equal v naught square plus 2gs. V squared equals 0, v naught equals 0 plus 2 multiply 9.8 meter per second squared multiply 10 meter. Then the velocity v equals 14 meter per second. 14 meter per second, the velocity of the body before the impact with the ground directly. Now, What is the velocity after the impact with the ground? Velocity after the impact of the ground directly is V naught, and V squared equal V naught square minus 2GS. V at the maximum height equals 0. 0 equals V naught square minus 2 multiply 9.8 multiply 2.5. Then V naught equal 7 meter per second. Now we can use the relation delta H equals M multiply V dash minus V. The mass equals quarter kilogram and V dash 4 minus V negative 14 meter per second, because the ball is impacted with the ground and rebounded upward after the impact directly. Then delta H equals 5.25 kilogram times meter per second, or 5.25 Newton second. And we know that the impulse I equals Ft. Then Ft equals M multiply V dash minus V. The impulse force F multiply the time 1 over 10 second equals 5.25 Newton second. Then the magnitude of the force F equals 5.25 in Newton unit. Now, what is the reaction of the ground? We know that F equals R minus mg. The magnitude of F equals 5.25 Newton equals R minus quarter times 9.8. Then R equals 52.5 Newton plus quarter times 9.8, which equals 52.95 Newton, because we use kilogram, meter per second, Newton second, the units of this example. Another example. The opposite figure represents the force time graph. Then the magnitude of the impulse of F within the time interval closed 0 and 5 in Newton second equals 12, equals 16, equals 20, or equals 25. Now we know that the impulse I equal the change of momentum. Change of momentum equal the area under the curve from t equals 0 till t equals 5. Then I equals integration f dt from 0 to 5 equals the area of the trapezium. Area of the trapezium equals half the sum of the two parallel bases P1 plus P2 multiply the height of the trapezium. Then I equals half multiply 5 plus 3 between two brackets times 5. Then the impulse I equals 20 Newton second. Another example. Then what is the impulse of F within the time interval closed 0 and 5 in Newton second? Equals 20 Newton second. Then we can choose the letter C. Now student, if the force F act on the body in the interval from 0 to 1, what is the impulse in this case? The impulse in this case equals the area of the triangle from t equals 0 till t equals 1. The area of the triangle equals half base times height. Half times 1 times 2 equals 1 square unit. In this case, the unit of the impulse equals Newton second. And in this case, what is the impulse if the time interval from 2 to 5? Equal the area the impulse equal the area under the curve from t equals 2 till t equals 5. From t equals 2 till t equals 5 is a rectangle. The area of the rectangle equal length times width. The length of this triangle equals 5 units and the width equal 3 units. Then the area equals 5 times 3 equals 15 square units. But the impulse here equals 5 times 3 equals 15 in Newton second unit, because the force here in Newton and the time in second. We can choose the units in Newton and time in second according to the given data in the opposite figure, because the opposite figure represents the force time graph and the magnitude of impulse according this given equals Newton second unit. بكده أعزائي نكون استعرضنا مع بعض موضوع من أهم موضوعات منهجنا، موضوع impulse. عرفنا إن الامبلس ممكن أتعرف عليه أو أتوصل له من الفورس والتايم I equals ft، أو أجيبه عن طريق change in momentum اللي هي delta h equals m multiply between two bracket v2 minus v1. عرفنا اليونتس اللي بنستخدمها، كمان عرفنا ازاي اقدر استخدم الانتجريشن لو انا عندي فانكشن ان تي، وكمان لو عندي جراف عرفت ان رسمه الجراف دي رسمه غنيه، الجراف دايما غني بالمعلومات، اعرف من خلال الجراف ده اوصل للامبلس عن طريق الاريا اندر ذا كيرف بتوين تو تايم انترفلز، هو هيكون طبعا مديها لي في السؤال، وبكده اعرف اجاوب على السؤال سواء كان انتجريشن او سواء كان جراف او كان سؤال عادي. Dear students of grade 3 secondary, by this example we come to the end of our program today. Till we meet again, it's goodbye.